Nope, we're recording now. My goodness. Okay, so we're going to start with a permutation. Permutation is, we've gone pretty far in this book so far. This is good. We're going to slow down. A permutation is an ordered arrangement of objects. The big important word there is the word ordered. Find the number of ways you can type in a 4-digit code with no digits repeated. So we want this one to be right, and this one to be right, and this one to be right, and this one to be right, which is why I'm writing multiply, because I'm saying the word and. It's not like when you type in a 4-digit code to get into somebody's garage, if you get one of the numbers right, you're good. You know, like it needs to be all 4 of them. How many choices are there? It says no digits repeated. How many choices are there for the first number? 10? And then 9, 8, 7. Okay, so we're going to use something in your calculator. Everybody type in 10 times 9 times 8 times 7. There's something in your calculator, it's an exclamation point, and it means factorial. And what that is a factorial, like if I wrote down like 5 factorial, I'm just going to write this on a separate piece of paper. If I wrote down 5 factorial, it looks like that, like 5. And what that means is 5 times 4 times 3 times 2 times 1. So just multiplying all the numbers, counting down. But this isn't really all the numbers counting down, is it? No. This would be 10 factorial divided by, what are we getting rid of? 6 factorial, because we're dividing away that 6 times 5 times 4 times 3 times 2 times 1. So the permutation formula would be, let's see, how do they actually write it? N, big P, little r.
You said permutations is and in the sentence?
Yep. No, but it's like if you're typing in a 4-digit code in a garage, you have to get the first digit, and you have to get the second digit right, and you have to get the third digit right, and you have to get the fourth digit right. So you're just going to have to kind of assume it. Because you can't be like, I'm getting into a garage, ooh, I got the third one right, so I'm in. Like, they have to all be there, right? It can't be an or, it has to be an and. So NPR, where N is the number of choices, and R is how many you want. So example 5 would have been 10 permutation 4. There are 4 choices, 4 numbers we can pick. 10 choices we can pick from. We want 4 of them. And we do care about them in order. Why do you care about them in order if you're trying to get into a garage? Right, unless, of course, they're all 8s or something. But if they're all different numbers, the order does matter, right? You can't just type in the 4 numbers and be right. So can anybody do the formula for me? So this is 10, right? And that's n. And that's on top. So this would be n factorial on top divided by. How do I do this? He had 6, but we were choosing 4 of them. 6 divided by what? 6 divided by 4 is not. What's the relationship between 10, 4, and 6?
These are choices.
Mm-hmm.
You want 4.
Yep.
6 is
Agreed. But what do you mean by leftover? You're missing a really basic word that you're talking about.
the opposite. What's that word?
Subtraction?
Oh, yeah.
Yeah. So this is n minus r factorial. So I'm going to show you how all of these work. You could do 10 times 9 times 8 times 7. There's also factorial buttons in your calculator, so we're going to try that right now. Okay, everybody type in 10. And then you're going to hit the math button on the side. Go over to probability. Do you see how the fourth one down is an exclamation point?
Mm-hmm.
Okay, hit that one. And then divided by 6 factorial. Also 5,040. Or you could use, there's actually a permutation button, so you could write 10 and then hit the math button again. Go to probability. Is it probability? Yeah. And then number 2, the second choice, NPR. And then type in 4 because it was, I have 10 choices and I want 4 of them. 5,040. So any of those work. Using the factorials work, using the actual formula in the calculator works, or just doing 10 times 9 times 8 times 7. All right, a psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick a first, second, and third activity? Do you see how it says the words first, second, and third? That implies that the order matters. As in, we care which one comes first, which one comes second, which one comes third, which says that it's going to be a permutation. Yes. So you could write 8 times 7 times 6 in your calculator. Or you could write n, or 8 permutation, how many? 3. Or you could write 8 factorial divided by 5 factorial. Do you have to learn all of these? It depends. Are you taking the AP test? If you're taking the AP test, they might put this in many different ways when they're talking about it, so you have to be familiar with it. If you're not taking the AP test, for me, I don't care which one you use. Okay. A building contractor, oh, what did you guys get? 336. Anybody else? Building contractor is planning to develop a subdivision. The subdivision is to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. All right, so I'm going to draw a picture of an example. So maybe there's like 2 little ones, and then like 2 tall ones, and then like, I'm going to call this a split level, and then there's another 2 of those, and then some tall ones, and then a little one, and then a split, and then a little one. You don't have to draw this, just watch. Do you see I have 2 split-level houses, 4 tall houses, and then 6 little houses? All right, so this is an order, right? And we could look down the street and see that this is an order of the buildings. So order does matter. But what if I took this house and I switched it with that house? Would it look any different? No, assuming that they're all painted the same, they would look no different. That's what the word distinguishable means. How many distinguishable ways are there to do this? The only time you use the distinguishable formula is literally it's going to say the word distinguishable in the problem. Okay? So to do this, instead of doing like, how many houses are there? 1, 2, 6 plus 4 plus 2, 12. So normally we would do 12 factorial and you divide by how many you want, right? But instead, we're going to divide by the different kinds. So I'm not going to, sorry, that's the wrong place to write that.
So would it be like 12 factorial divided by 6 factorial?
Yes.
And then divided by 4?
Yes. So it's 12 factorial divided by 6 factorial, 4 factorial, and 2 factorial.
All separate?
Yes, because that takes the different ways that you could like organize the 1 stories and the different ways you could organize the 2 stories and so on. So put it in your calculator right now. You are going to have to write it like this. There isn't a distinguishable formula in your calculator, and you do have to have parentheses around the bottom.
Factorial, and I just use each other.
No, they're not commas. It's the exclamation points.
Yeah, but do I have to put a comma after?
No.
13,860.
Yep.
You got the digits right.
13,860. Are you joking because you didn't do it right? Or are you?
You got 13.
Am I supposed to multiplications?
Nope. You could. You don't have to.
Oh, maybe so.
I'm going to put a divide sign. So if you go here and hit second insert, now hit enter. Okay. How about you, Tristan? You good? Okay. So a distinguishable formula is n factorial divided by n sub 1 factorial, n sub 2 factorial, n sub 3 factorial, depending on how many different kinds you have of things. All right, so you scoot over to your Post-it partner and try example 8 with them, please. Did you say it's time consuming to do this?
Yes.
So one thing you can do to make it less time consuming is if you hit second enter, you can just copy the one that you did before and just change the numbers. Then you don't have to go find the exclamation points.
So it is good. Time.
Whoa. 77 million is right.
That's crazy.
Isn't that crazy?
Yeah, I know. It could be 77 million.
Right, and that's not even and that's not even saying one maple tree is distinguishable from the other. Mm-hmm. That's just saying maple first, then 2 oaks, and then a maple, and then 5 poplars, and then 2 oaks. And there's 77 million different ways you could do that.
Could we do this for Rubik's Cube?
Well, it's because.
Could we what?
Could you do this for Rubik's Cube?
Yes, you can. You can. You can actually figure out also, with a Sudoku, how many different ways there are. Because people are always like, aren't they going to run out of Sudokus you could do for a Sudoku book? No, they're not, because it's in the billions of different ways they could do Sudokus.
And they could just move a 9 over.
Yeah, well, I mean, if you move a 9 over, the rest of it moves over. Yeah. So, there's a lot of different ideas for the top row. And then as they go lower and lower and lower, it's less options because they're formatted by the top row. What's up?
Nothing. Figured it out.
Okay. This is why statistics is my favorite. I think it's wild, this stuff. Can you imagine if I was okay, start making pictures, draw out one way you could do oak trees and maple trees and poplar trees. Okay, now list all the ways. We would just die. We would die in here before we even got close to listing all the ways we could do it. Even if we just wrote the word O or O, M, and P and didn't draw pictures or anything, we would all perish. If everybody in the school all worked on it at once, we would all die before we could do it. Okay. Yeah, 1 million is... I think you could count to 1 million if you're given enough time. I actually have a calculator that will tell us to do that, which we can do during Pi Day if you want. It's really fun. It times you on how fast you can count, and then it'll tell you how long it'll take you to count to 1 million or 1 billion or whatever. Okay. A combination is
Combination.
trying to think of the best way to write this. It's selecting objects or whatever, people, from a total without caring about order. So if I said to you, how many different ways are there for my class of 20 kids to line up at the door? Well, there's 20 choices for the first one, right? 19 choices for the second, 18 choices for the next. Do you know why I'm counting down?
Yeah.
Because we're not counting the kids we already talked about, right? So that's 20 factorial. So how many different ways are there for my class of 20 to line up at the door? That many ways. That 2.43 means I move the decimal place 18 times after this. This number is too big for the calculator to give you. Okay, now how many ways could they line up at the door if I don't care about order? 1, they line up. Okay, so permutations are always going to be like a much bigger number than a combination, which doesn't matter as much. So this one says, a State's Department of Transportation plans to get 16 bids for a project. They plan to hire 4 of them. Okay, why do you think it doesn't matter this time the order? We got 16 companies, we want 4 of them, yeah?
They're just hiring them.
They're just hiring them. It's not like they're going to be like, well, who'd you hire first? Like, it doesn't matter. It just matters who we got. So this one's a combination instead. This would be 16 combination 4 or 16 choose 4, it's often said. This formula is n factorial, just like the last one, and then n minus r factorial, but then also r factorial down here.
Is that all?
Yep. So this is n minus r, and then r next to it. So if I was to write this out, I'd say 16 factorial on top, and then 16 minus 4 is 12 factorial, and then I'd also do 4 factorial, and that would be a combination instead of a permutation. So let's try the one with exclamation points first. So type in your calculator 16 factorial divided by parentheses 12 factorial times 4 factorial. There's still 1,820 ways I could pick 4 companies. That's quite a bit. And then everybody type in 16 in their calculator and hit math. Go over to probability. This time choose NCR. And then type in 4. That. If instead I did NPR, the difference between the two. If I cared about order, 43,680. If I didn't care about order, 1,820. Big difference. All right. Find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. All right. So when it says probability, that means I'm probably going to want to set up a fraction, something out of something, right? How many cards are in a deck? 52. So there are 52 cards in a deck. Okay. When I get cards for poker, am I allowed to rearrange them in my own hand?
Yeah.
Yeah. I mean, it's not like I'm like, man, I would have a royal flush if only they weren't in this order. If only I could move the king over there, I'd have a royal flush. Like, no. You can rearrange them. So this is a combination. How many cards are you drawing? 5. So that's the total number on the bottom. 52, choose 5. On the top, we only want diamonds. How many diamonds are there? 13. 13 diamonds, and we want 5 of them. Nope. I got 4.952 e to the negative 4. You guys get the same thing? So what does the e to the negative 4 mean? I have to move it. Do I move the decimal to the left, or do I move it to the right?
Or negative.
It's negative, so it's going to go to the left. 1, 2, 3, 4. So it's 0.000495.2. That's the probability of you getting only diamonds without any change in poker. But it is not the probability of you getting a flush. A flush is when you get only something from one suit. So what would I have to do to it if I wanted to make it a flush? Because this is just diamonds. I could have gotten all hearts, right? Or I could have gotten spades or clubs. So if I multiply this by 4, that'd be the probability of getting a flush. Okay. All right, here we go. Food manufacturer is analyzing a sample of 400 corn kernels. By the way, this is pretty accurate. They use this kind of stuff all the time in food manufacturing and in product placement. 3 kernels have dangerously high levels. 4 kernels are randomly chosen in the sample. What are the chances you get exactly 1 toxic kernel? All right, so how many? It says, what are the chances? So I'm going to make it a probability. How many corn kernels are there? 400. And how many am I picking? 4. And I don't care about the order I get them. I just care what I get. That goes in the bottom. Okay, how many? I want them to be, I want exactly 1 toxic kernel. How many are not toxic? 397. And I want 3 of the non-toxic ones, right? Times. Now let's do the toxic one. How many toxic ones are there? 3. And how many do I want of that? 1. On this one, you will... No, I don't. You still don't have to even put it with parentheses in your calculator. All right, last one we're doing. Find the probability of getting a 2 of a kind. Am I moving too fast? Are you guys okay with this one? Probability of getting a 2 of a kind hand in poker made up of only aces and 3s on your first draw. All right, what should go on the bottom? 52, choose. 5. What should go on the top? We got to do aces and 3s. And it's 2 of a kind. Do you know what 2 of a kind means?
2 of the same.
Mm-hmm. So, hold on. 2 of a kind. It's not 2 pairs, is it? made up of aces and threes. I don't like this. Let's say 2 pairs. Okay. I just wrote that incorrectly in my notes. So, how many aces are in there in a deck? 4, and how many do we need? 2? How many threes are in a deck? And how many do we need? 2? But there's one more card, right? Because you got 5. So I'll have like if I had an example hand over here, I'd have 2 aces, 2 threes, and then what? A 5. It just can't be another ace or a 3, right? Because if it was an ace or a 3, it'd be a full house. So how many cards are left that aren't aces and threes? 44. 52 minus 8.
Choose one.
Mm-hmm. So 52 cards in a deck. 8 of them are aces and threes, right? This is actually some pretty complex combinatorics. It's also my favorite kind of math, so I go a little deeper than I need to probably here. Did you do this kind of stuff in college?
Yeah.
I got .000006. No, I did it wrong. 3 zeros and then a 6. All right, this whole shebang is due tomorrow. And this is, are you ready for it? This is the last big assignment in this class. After this, we are slowing down. Tomorrow we're going to do a review. The next day we're going to do Jeopardy. Then we're going to take a big test on chapters 1 through 3. The nice thing about this is I'm not going to make you make a note sheet. You can use all of your notes on the test and reference anything you want when you're taking it. And then we will really slow down. We'll do like 1 lesson a day, like a normal class. It'll be nice. This is everything I cover in intro stats. I usually go to chapter 5 a little bit and do a little bit of normal distribution stuff, but I'll take that for you guys.
Oh, I found my pen in my book. Yeah, I remember doing this. And then we touched it in college.
I took a whole class on combinatorics in college. Because I went to UW-Madison, and if you're a teacher at UW-Madison, like a secondary ed teacher, you can either specialize in calculus